This video is to show you how to do multiple regression in Excel using the Data Analysis Toolpak. So I'm grabbing an example here from, it's a problem from a textbook here, 14.1.8. We're talking about appraised values of houses, property size, and age of the house. Okay, so in a certain town, approximately 25 miles east of a large city, we've collected 20 single-family homes located in this town and recorded their property size in acres, their age, and their years old that they are. Okay, so we're going to run this regression here, get this result. How do we do that? Under the Data tab, go to Data Analysis, and down to Regression. And we want to forecast the appraised value, so that becomes our y. Whatever you're looking to forecast is your y. Whatever you're using to forecast it with is your x, or your x's. So property size and age are going to be our two forecasters. Include labels because I checked off, or I selected the top row here where there was labels. Confidence level, let's just spit out a 95% confidence level. Okay. That's a standard. You can look through the problem or any problems you're working on and see if they want a different confidence level than that. And then output range, you can choose where to put this. I'm going to put it just down below the data here. And always good to spit out the residuals. Very good. Residual plots are not a bad idea. You can make those on your own, but might as well. And then the normal probability plot's a good one to look at to check to see if your data is normal or not, or sorry, if your residuals are normal or not. Click OK. Little note, one of the regression assumptions is that the residuals generated from regression must be normally distributed. Okay, so here's our output. So this is good. We got what my answer key also shows. So I just have the completed problem from this example up here. So all my numbers check out. Okay. Now, first question is to interpret the slope from this problem or from this model. Okay. For B1 and B2. So for, in this case, property size and age, we're going to call property size, essentially we can call it our first variable, call it x1, and age, our second variable, call it x2. Gorgeous. And so the slopes, which are the sample slopes, we're going to call B1 and B2. Okay. Now, to interpret the meaning of them, we have to watch the units here as well. Age is in years and property size is in acres. That helps us. And the appraised value, let's take a look, is in thousands of dollars. So if we want to interpret these two slopes, this guy and this guy, let's just put our answers. Let's see here. I'm going to hide a bunch of the data for now. Put our answers up here. I'll just drop the plots down. This normal probability plot's really useful to look at. Okay. So meanings of slopes. Let's first talk about that. So first one here, property size. For every extra so meaning of the slope, for every extra 1 unit increase in the x, the slope tells you how much the y increases. So in this case, for every extra 1 acre increase in property size, or you could say for every 1 acre increase. Extra and increase kind of say the same thing. When we're talking about acreage, it just sounds better to say increase. Okay, so for every extra 1 acre increase in property size, the appraised value will increase by, so we've got the 464,695.71. Now, that was for 464 originally, but I'm going to times that by 1,000 because the property values or appraised values were in thousands originally. Okay. Second interpretation here is for the age. So for every 1 unit increase in the X, so in this case, for every extra year old the property, or really the house is. So for every extra year in age, the appraised value of a house or property will increase by, and in this case, actually, forgive me, since this number is negative, we're going to have a decrease. So for every extra year old, the places that make sense, the value of the place is going to go down. And in this case, it's going to go down by $2,629.11. Perfect. Now, part B, let's take a look at that. Oh, sorry, that is part B. Part A is just this output here. So we're on to part C now. Explain why the regression coefficient B0 has no practical meaning in the context of this problem. Okay, so what the heck is B0? B0 is our, this guy right here, it is our sample y-intercept. So if we were doing, generating the equation for a population, if we had all the population data and we're running regression, we would call this beta 0. If we just have a sample of data, in this case just 20 data, we call it B0. And right now it's 404,263. Now, what would this be? So the y-intercept, which is B0, which equals, in this case, $404,263.77. This is the value of a property or house with no land, basically. So there's no property here, essentially. Your property size is exactly 0. And the house or building is 0 years old. Now, you could argue this could be a brand new house, or actually then really a brand new apartment if there was no property at all. But in this case, we're actually talking about houses and not apartments. So this number doesn't have any meaning. So mainly it's the property size itself that makes no sense at being 0 if we're talking about a house. So no, we cannot have a property size of 0 acres. So what happens is y-intercept doesn't have any real meaning because we can't have an x value, an x1 value of 0. It makes no sense. So what this value really means, it's just a placeholder. It's the y-intercept for the best fit line to our data. So when you're drawing or running a line through your data, it just happens to be the best fit, really. So it's just if you're fitting your straight line, let's say this was your data, although it's not, but let's say you're fitting a straight line through here, it's just where the line happens to pass through the y-axis. But again, it doesn't have any actual meaning because we can't have a property size of 0. Moving on to the next part here. If we want to run a prediction, So let's say we're predicting the appraised value for a house that has a land area of 0.35 acres and it's 45 years old. So when you want to run that prediction, fairly nice and easy. Let's run one of those. I'm going to bump these graphs down lower again. So part D, predict land value for house with 0.35 acres and an age of 45 years old, and is 45 years old. So you just take your y-intercept plus the 464 times 0.35 plus, because that's your land size, plus the 2.69 times 45 in this case, and times the whole thing here by 1,000. Why? Because that is the units for y. It's in thousands of dollars. Do you want to make this answer look even better? Turn it into a dollar amount. Okay, so that's your prediction. And next one, construct a 95% confidence interval estimate for the mean appraised value for houses that have a land area of 0.35 and acres is 45 years old. So next thing is to build up that confidence interval. This is very important. So really this prediction holds no weight unless you look at its confidence interval associated with it as well. So yes, you can predict a value of 448,000, but how accurate is that? Well, your confidence interval is going to tell you that. So let's go build up that confidence interval.